Okay, guys, we're on to the second topic for today, which is solving logarithmic equations. And this is really the main, like this one and the first topic are the main two. I'm going to do a third topic and third video, but that one's kind of actually bonus. I'm not even going to require that you turn that one in. That was more for you to just kind of peripherally be aware of what we call logistic growth, logistic equation growth. And then that problem will help you with the last question on the homework as well if you need that extra help. Okay, that's the only purpose of the third video. So the meat of it is going to be topics 1 and 2, and that's where your exam questions are also going to come from. Okay, so this is topic solve logarithmic equations, and when we were solving exponential equations, we attacked it with logs on both sides. When we solve logarithmic equations, we attack them with exponents on both sides. So here's a reminder of the inverse property. If you have a log base a, right, and you take a to that, so notice that the bases match here, right? If I take a to the log base a of whatever I have in the inside of that, then it spits out whatever the inside was. And this m, it could be a number, but it could also be an expression involving x's or whatever other variables. Now, using that inverse property, let's do a quick example. Let's say you have some log function right here, right? I want to solve this thing. How will you solve it? We look, okay, what's my base? The base was 2. So I'm going to hit both sides with the 2 base and raise it as an exponent. So 2 to this log is 2 to that. And since those things were equal to each other originally, when I raise them both, raise 2 to the power of those things, then the result is still equal to each other, right? But the thing is, raising 2 to the log base that, it cancels the log out, giving me only this piece left over. And that's what this process showed right here. Okay, I just kind of show those steps in real time. So that's basically it. Summarizing the strategy. What do? You just attack both sides with an exponential function, and not just any exponential function. You attack it with a specific exponential function that matches the base of the log. Okay, big caution here though. Once you finish solving, you get down to this thing, you solve for x, make sure that your solution actually makes sense. Because remember, if you look at the log functions, you can only take logs of numbers that are bigger than 0. So 0 is, first of all, not impossible. Negative is also not possible. And then you can remember back to the definition when we first introduced logs. We had something like log base a of, well, I forget what letter we used. B? Something like that. And when we said, okay, a has to be bigger than 0 and a cannot be equal to 1, right? So that's the other thing. The base cannot be 0, or it's got to be bigger than 0 and it cannot be 1. And then also this number here, b has got to be bigger than 0. You can't take logs and get a negative number because the base was positive, right? So b is also bigger than 0. So make sure that when you figure out your answer, that doesn't violate one of those two things, where it's going to make the base negative or 1, or it's going to make the inside of the log a negative. All right, that's basically it. There's one more thing here about, you could use a property where if you have two logs equal to each other, then that means the things are equal to each other. But really, this whole thing to me is not even really necessary, because when you start attacking with the exponents like we talked about here, this is going to end up happening anyway. What's written in this box is going to happen anyway. So I wouldn't even worry about that. I just put that there because it's analogous to what we did with the exponential functions. So it's worth knowing that it does work in both cases. But yeah, like I said, I wouldn't even bother using that fact. All right, let's try the next questions, guys. So strategy here, we're gonna spend this video doing the first half of these questions, 16 to 30. Next video doing the rest, and that's gonna be basically the end of the section. And then after that, I'll add the bonus video where we go over that third topic. Okay, so here we go. Number 16. Let's read the directions first. Solve. What am I reading? Find the solution to each equation. First, give the exact answer. Then provide a decimal approximation to the nearest two places. So it's kind of similar to last time. Okay, 16. A log base x squared. Oh, that's kind of weird. Of 2x equal to 1. And here the base is x squared, right? So I'm going to attack it with the exponential. x squared raised to this thing is x squared raised to that thing. X squared raised to the left of the equation is x squared raised to the right of the equation. Now what happens when I raise x squared to this log though? Remember they're inverse functions. So these guys just basically cancel each other out, giving me just 2x on the left. And the right x squared to the 1 is x squared. Okay, that's looking very nice. How do I solve this thing? Well, let's move all the x's to one side. I'm going to move it this way so that my x squared will stay positive. So I subtract 2x on both sides. I get 0 is equal to x squared minus 2x. And then from there I can factor. So I get 0 is equal to x times x minus 2, which means x must be 0 or 2. All right, so I got two solutions to check. Let's check 0 first. Okay, if I plug in 0, I've got log of 0, which is no good. So this guy is out. 0 is not a solution. If I punch in 2, this is going to be 2 times 2, that's 4. That's a positive number, that works. And down here, the base, 2 squared is 4 as well. So that works. So 2 is okay. 2 is good. X equals to 2 then is my one single final answer. Box that thing, and then done. 16 is done. Moving on. Got some ASMR going on with the tapping of my eraser pen. Okay, here we go. 17. Log of x plus 20 equals to 2. Okay, what do we do with this thing? Well, log, remember, is a common log. If it's not explicitly written, we understand that's log base 10. So I'm going to hit it with the exponential 10 to that thing and 10 to that thing. The 10 to this, 10 to log base 10 undoes each other since it's inverse, giving me x plus 20 on the left. The right 10 squared is 100. So now I subtract 20 from both sides. I got x equal to 80. Double check now. Does that make sense? If x is 80, this is going to be log of 100. That's okay. And the log base didn't change. So x equal 80 makes sense. That is your answer. Okay. That's 17 done. All right. Number 18. And as we're going, you notice these are pretty simple actually, right? Not too hard, yeah? Okay, I got log base x. So I want to x to that thing. X to that thing. And remember, x undoes it because it's inverses. So I get 16 is x squared. Take square roots. X is plus or minus 4. Okay, we got to check these individually. So let's check them. X equal to 4. Let's do negative 4 first. And x equal to positive 4. If I plug in negative 4, I'm going to have a negative 4 base here. And that's no good. Because bases, remember, had to be positive. They also cannot be 1. If I plug in a 4 here, that's base of 4, and that is totally fine. So that means x equal to 4 is my one solution there. Okay, that was 18. Okay, plan for this video, is to do, let's see, 8 questions. So that's 8, 1, 2, 3, 4, 5, 6, 7, 8. That's right here. Yeah, okay. Okay, number 19. Log of this big thing, x squared minus 5x plus 16 equal to 1. And remember, I just like to write it in, even though, you know, they just write log for shorthand, and that's what appears as your calculator. I like to write it in so I explicitly remember what it is. Okay, that means I want to raise 10 to that power of log base 10, right? Again, those guys undo each other, giving me x squared minus 5x plus 16 on the left. And on the right, 10 to the 1 is 10. Okay, to solve that thing, subtract 10 both sides. I got x squared minus 5x plus 6 equals to 0. And now let's look to factor this thing. Can this thing factor? Well, two things that multiply to 6 and add, or subtract rather, to negative 5. That would be x minus 6 and x plus 1. So that means x equal to 6 or x equal to negative 1. Okay, let's check if those things make sense. So if I plug in 6, this is going to be 36 minus 5 times 6 is minus 30. 36 minus 30 plus 16. Okay, that's no problem. That's a positive number, so that is okay. Negative 1. If I plug in negative 1, I'm going to get 1 here. 1 here. Minus 5 times negative 1 is plus 5. So that's okay. And then plus 16, that's okay. Everything stays as positive. So both of those are okay as solutions. And that looks terrible with those check marks. Okay. 19 done. Okay, 29, 20, no, what? 20. Okay, log base 4 of x squared minus 7x plus 14 equals to 1. The base was 4, so I'll raise 4 to the power of the log and 4 to the power of 1. Yeah. And the 4 undoes that part, giving me x squared minus 7x plus 14. And the right, I have 4 to the 1, which is 4. Subtract 4 on both sides. I got x squared minus 7x plus 10 equal to 0. And is that factor? Okay, I want two things that multiply to 10, subtract to 7. That would be x, x minus 5 and x minus 2. Yeah. Negative 5 times negative 2 is positive 10. Negative 5 plus negative 2 is negative 7x. I didn't say that correctly. Negative 5x plus negative 2x is negative 7x. Okay, that means x is equal to 5 or 2. Let's check both of those things. If I plug in 5 here, it's going to be 5 squared 25 minus 7 times 5 minus 35. That's negative 10 plus 4 is positive 4. That works. If I plug in 2, it's going to be 2 squared, which is 4 minus 7 times 2 is 14, and that's going to be 4, so that works. So both are okay. Both are viable solutions. Yeah, I'm not taking a log of a negative in either of those situations. And notice the answer came out 4, right? 4 to the 4 is equal to 1. I'm sorry, no, I said it wrong. 4 to the 1 equal to 4. So log base 4 of 4 is 1. Yeah. Okay, 21 natural log of 2x minus 3 minus log. Okay, I see. X plus 5. So for the first time, here we have 2 logs, right? 2 logs. So how do we deal with that thing? Well, we actually just combine it to make a single log using our rules of logs. And this is why we practiced in the previous section, section 3.3, on how to do that kind of thing. So here, minus, right? The thing about logs, remember, is if I have a minus between 2 separate logs, I can combine them as a log of the difference. No, I'm sorry, I'm saying the wrong word. The quotient to mean. The 2x minus 3 at the top divided by x plus 5 on the bottom. Right? What does log do? If I have a log of a division, I can separate it into 2 logs using subtraction. That's what the rule of logs say. Okay, so now I got this thing. How am I going to solve it? The same way I usually do. Remember, natural log is a base e, right? So I want e to that and e to the right side. E to that. Okay, on the left side, e undoes the natural log, and I get just 2x minus 3 over x plus 5. On the right side, e to the 0 is just 1. Beautiful. Okay, how do I solve that? Multiply both sides by x plus 5. I get 2x minus 3 is equal to x plus 5. And then subtract x on both sides. I get, here, let's write it this time. I never do this, but I'm going to do it this time for some reason. Okay, the 2x minus x is x. These guys cancel. Those guys cancel. 5 plus 3 is 8. So x is equal to 8. Okay, I'm about to box it, but let's just double check. If I plug in 8 here, that's going to be 8 plus 5. No problem. That's positive. Plug in 8 here. That's positive. So no worries. X equal to 8 is a viable solution. Okay, 2 more for this video, 22. I feel like these guys aren't so bad, right? But to me, I think these are almost easier than the exponential functions. And so far, authors have been very kind to give us questions that all end up pretty much being integers. Watch me eat my words. Okay, let's see. This is 2 separate logs again, right? So I want to combine them. This time plus in between. So I can combine them to a single log with multiplication instead. So it's going to be log base 2 of x plus 2 times x minus 2 equals to 5. And here I'm going to do the usual thing and attack it with the exponent. So where it's 2 to that thing and 2 to that thing. If you're just listening, 2 to that thing, 2 to that thing is so descriptive and so helpful. 2 to the left times 2 to the left equals to 2 to the right. This guy undoes each other, so I get x plus 2, x minus 2, and the right 2 to the 5th. 2, 4, 8, 16, 32. Yeah. Okay, how do you solve something like this? Well, this side is not 0, so this being factored is not very helpful. So what I have to do is just multiply this thing out. X plus 2 minus 2 is x squared minus 4. Nice thing about it is it's a difference of squares, yeah? That's 32. Add 4 to both sides, I got x squared equal to 36, which means x equals 2 plus or minus 6. Let's check those individually. Okay, if I plug in negative 6 right here, I'm going to get log of a negative number. So that guy is no good. Or as they say in Japan, NG. Isn't that strange? I didn't know what that meant the first time I heard it. And then I found it as no good, but like we never use that thing in English. Okay, x equal to 6. X plus 2 would be 6 plus 2 is 8. That's no problem. 6 minus 2 is 4. Also no problem. So x equal to 6 is a viable solution. Okay. Last one for this video. Okay, 23. I got log of x minus 3 over 2 plus log of x plus 2 over 7 equal to 0. Okay, and as usual, we're going to combine into one single log. We got a plus in between. Oh, I like that purple. We got a plus in between, so to combine them, I'm going to multiply. I'm going to get log of x minus 3 over 2. I said 2 and I wrote 3. That must infuriate you that you're watching. Times x plus 2 over 7 equal to 0. And I want to undo a log. Remember, this is a log base 10. So to undo it, I'm going to write 10 to that. And 10 to the left side undoes the log base 10, giving me x minus 3 over 2 times x plus 2 over 7. And 10 to the 0 is just 1. All right, now, the thing that makes this look ugly and seem like it's more harder than it is the fact that you have those fractions. So let's just get rid of those things by multiplying by the bottoms. So multiply by 2, multiply by 7. You can multiply by the least common denominator. And in this case, it is actually the same thing because they're primes. They don't have anything common. So multiply by essentially 14. I'm doing it 2 steps. Multiply by 2, that cancels that out. Multiply by 7, that cancels that out. And then on the right is 2 times 7, that's 14. Or if you more accurately, 1 times 2 times 7. Yeah. So left side I have x minus 3 times x plus 2. Let's multiply that out. That's x squared minus minus 6. Equal to 14. Let's subtract 14 on both sides. That'll give me x squared minus x minus 20 equals to 0. Now I'm hoping to factor this thing out. I want things that multiply to 20 and subtract to negative 1, or add to negative 1. And that does have a factor. It's x minus 5, x plus 4. Negative 5x plus 4x is negative x. Negative 5 times 4 is negative 20. So perfect. Okay, that means x equals to 5 or x equal to negative 4. Now let's check each of those. starting with 5. Okay, if I put 5 in there, 5 minus 3 over 2 is positive, no problems. 5 plus 2 over 7 is positive, no problems. If I put a negative 4 in, negative 4 minus 3 is a negative number. Over 2 is still negative. So this guy is no good. X equal to 5 is correct. That's your only answer. Okay. All right. See you next video.